So let's start with this. All right. So imagine that this whole part in the middle of the page is the internet. So imagine there's a cloud drawn here, and this is the internet between these two branches. We've got a west branch, and this west branch has got an INET A, and we've got an east branch somewhere far away. There's a bunch of internet between these two branches, and we want to optimize connectivity between them. So let's say that we take these two devices, we add INET A, and we apply a real-time overlay, and we connect them up. So first thing that's going to happen, of course, is that we're going to see an underlay tunnel formed from INET A on the west side to INET A on the east side. This is what we do every day. Very, very straightforward. So let's assume that we have this premium ISP 18.6 ASN 16.541. Could be AWS, could be Azure, Equinix, Megaport, any of the different folks that will let you essentially buy transit from them. So you go and you buy this thing. Now, first thing you do is create a third-party IPsec tunnel from the edge connect to the closest on-ramp point, or edge, as most of them would call it. And this will be geographically located. So maybe the West Coast edge connect over here is going to connect to an AWS on-ramp in California, and this guy edge connect east branch on the right is going to connect to an IPsec endpoint in Virginia, potentially. All of this space in between the two is the premium ISP's backbone. It's their network. There are no hops. It's highly optimized. So now let's say that we actually want to route a IPsec UDP tunnel, a fabric tunnel, or what we call an underlay, across that, inside that third-party IPsec tunnel, through the IPsec on-ramp endpoint, across the provider's backbone, and then out the other side to the other edge connect. This is what we call a tunnel-in-tunnel use case. So you can see here that we've created an additional WAN side label called INET A. It should be underscore ramp with a dash. We don't support dashes in label names. So INET A underscore ramp 1 on this end, and we've got INET A underscore ramp 1 on the other end. These two IPs, 1050.21.1, can ping 1050.22.1. It's a basic assumption that there's an anycast path that has been established across through that IPsec tunnel, across the premium ISP's backbone, and out the other end, back down the other edge connect. So from the edge connect's perspective, it's just another WAN side label. It's just another WAN side interface. And that is fundamentally what the tunnel-in-tunnel feature is. It's about establishing path diversity and allowing the bonding mechanism that we have, path char and all the other mechanisms we have to figure out, all right, if I've got multiple underlays, which one should I pick right now? And switching them, nearly 600 milliseconds, we switch from one underlay to another. And in HA mode, high availability mode, it's seamless and instantaneous. So we do a very good job of having multiple discrete paths and picking and switching between them. It's fundamentally what overlays and tunnel bonding and DPC and path chart and all that stuff do for us. So this is leveraging that strength that we already have. We're setting up, we still have our existing INET A to INET A underlay that's just going raw across the internet. But now we have this additional path that we've created. We source a packet from the VTI itself, and then send that packet, that tunnel packet, that IPsec UDP fabric tunnel packet through the orange pass-through across the other end, and we sync up, and now we have two underlays active between these two endpoints. This label here, this label dropdown, is functionally the same label that you have in the deployment page. You got to think of it just like that. It's like you're doing the same thing. You're essentially, when you go into the VTI and you interact with the label dropdown, you're picking a WAN side label just as you would pick a WAN side label in the deployment page to source the direct INET A to INET A flow, or INET A to INET A tunnel. These are functionally the same thing, which means that now that for this VTI, for this INET A ramp 1 thing, you can use that label that you've selected here in your BIOS just like you would any other WAN side label. You cross connect it or don't. You put it in the bio, in the primary or secondary position. You just design it however you choose, depending on the requirements. But the fact is that that tunnel now behaves like and adopts all the functionality that we're provided through our business intent overlays for normal WAN side labels. This page right here, this VTI panel, you guys probably recognize there's some changes that have occurred. You now have a label drop down. You have this, you might recognize this from the deployment page. It's a NAT, no NAT, manual NAT button. The same exact little dialogue that we have in the deployment page. It's on the VTI, because the VTI is essentially a WAN side label, a WAN side interface. It's just virtual, sort of inside the Edge Connect, as opposed to a physical Ethernet port that you plug in from the provider. So in the VTI, what you do is you configure the IP of the VTI source address. That's going to be the source IP of the resulting IPsec UDP tunnel. You tell it what label you associate it with. You can pick your NAT or don't NAT setting. And then you tell it what you have to, this is where this binding occurs. You tell it what pass-through tunnel this is associated with. In this case, we've got a pass-through tunnel. That's the original purple thing here was called INET_premium ISP. Then you pick a zone. So all the traffic coming in and out of this VTI or this pass-through tunnel will be marked with source or destination zone trusted here. We also introduce another, you can add an IP alias to a VTI. That's what it comes down to. And you might say, why would you guys even bother doing that? It's actually because in certain cases, AWS being one in particular, they, for whatever reason, mandate that the VTI between the branch and their on-ramp is a link local 169 IP. Now you can imagine how that wouldn't work here, because if you look at the top, if this 1050.21.1 is if that's a link local 169 IP, how am I going to route an underlay tunnel to the other end? I mean, even if you could send the packet to the other end cannot respond back to a 169.254 IP. So it creates a situation where you have to have a second IP that is logically sitting behind the link local 169.254 IP, and we use an alias for that. So this means is that if your VTI is forced to have a 169 address, you can click a little plus IP button that's right here, and then it switches and gives you a place to put the IP mask alias. This will usually be a /32. This becomes the source of the tunnel, and the 169 IP no longer is the source of the tunnel. That's also, that last thing we just talked about is also related to this other button, the auto distribute button, which is literally an override to an override. I think not pretty, but required in situations where an IP alias is in use and BGP is used to redistribute the alias into the ISP. That alias IP that we were just looking at, this thing is treated as a WAN side interface because it's attached to a WAN side VTI. And if we didn't have this auto redistribute override button, this alias IP would never be announced to the provider via BGP if that's how you're choosing to do it. This is the punchline, I think. So take that whole example we just talked through, where I've got a direct going this way, and it's got n number of peering points and hops, and I've got an optimized path that on-ramps early and then goes to the other end. This is literally an AWS example that we're showing here. The direct path is 285 milliseconds nominal, with, you can see this giant spike here, up to like 360, 400 milliseconds. This bottom one is the raw internet. This top view is the on-ramped underlay. So the Edge Connect in this situation, you compare these top to bottom. See, the times are lined up. So the Edge Connect would be choosing the top one because its latency is lower. So both high quality and high availability mode select based on the Hughes metric, which is a combination of latency and loss, and it would be choosing ramp 1.